This conference will now be recorded.
All right, all yours.
Oh, perfect. So, good morning, everyone. My name is Ravi, those who don't know me, and I'm part of Meta, and I'm also working with the team for Chiplet Business Work Group. So, last year we had a Chiplet workshop, business workshop, and we are also planning to do is something similar this year. So, these are some of the initial thoughts team have captured, how the structure should look like. That's where I want to get some feedback and see how community wants to see how this should evolve. So structure of the workshop is it could be in person or hybrid or remote. We don't know. I think we'll see how things will change. As a function of time, but things are moving in the right direction at least. Timing wise, April and May. Uh, And Bapi and folks, stop me anytime you want me to have a discussion. So talk wise, we are thinking of having some keynotes, and then like last year we had few sections, and then panels. And some of the theme for this workshop we have is, again, these are different themes which team propose. We have to just pick one theme, but the idea is maturing chiplet ecosystem. Where are we today? Or business of chiplet for everyone? Democratization of chiplets, chiplet ecosystem for everyone, chiplet evolution. Anyone that has any like, dislike, or preference on these themes? Okay. Okay, I'd like to be more
Reference to
interactive
what?
session.
I'm sorry.
Otherwise, it will become like I'll just read the document and we are done.
Hey, Ravi, reference to what? I'm sorry, I missed.
Sorry, say again, Tawfiq.
Reference to what? You're asking. I missed.
Tawfiq, it's very hard to hear you. I don't know if it's me or it's
Oh,
your.
is it better now?
Yes, it's much better now.
Oh, okay. So you said preference to what?
So
The
these
question.
themes,
Sorry, I missed.
so these themes, is there any preference to any of these themes? Again, we have to pick one theme. Eventually, we don't have to do it today, but if the okay, let me
So
still walk.
Ravi,
Mhm.
in terms of picking a preference, it would be nice for us to be able to figure out, or maybe the business work group is like, what is a before and after for 2022. You had the two deliverables, right? And maybe
So,
an agenda that works towards those deliverables.
so check this out. So this is like the how we think this workshop should be accomplishment from 2021, which is cost model, thermal modeling, known good die, right? So
Right.
known good die and cost model primarily came from that as part of that workshop deliverable, and then thermal modeling also came out after the workshop, and then JSAT and Meta work on it, and then there was a OCP Global Summit presentation. So this was like what happened last year. Then thought is, where is the industry today? And this is where we want to talk about maybe more like a we what ODSA, some of the other efforts are happening like OpenHBI, Bo, and some of the other folks in the industry who are working on. And then again, this is some general initial thoughts, but is that what you were asking, Bapi, or you were asking something else?
So I think in terms of this, right, you could organize the workshop around maturing the cost model as an example, going deeper into the cost model, or two new deliverables in your mind. I guess that's what I was thinking, that you want to organize it around deeper around the two deliverables that the business group had. Yeah, I'm not recommending it. I'm saying in terms of a before and after, if you have that, then and at least at my end, it's easier to sort of say, yeah, I like option A versus option B.
So maybe this will be a short one, but I think what we are saying is maybe we'll have a dedicated topic on maturing of the cost model, and likewise the non-good die work as a two thing. But the way I am thinking is, if we just the entire workshop will be focusing on those two topics, but I think I want to make it more generic and
Yeah. Okay, that was a question.
yeah, because like we did last year, right? So we didn't focus on to one thing, but it's more about, and especially some of these effort which is happening, and especially around Bo, as you know, we are still figuring out the business arrangement. How do we come up with this chip? I think we should use this as an opportunity to drive some of those discussion as well.
And if I may add, Bapi, we would also like to poll the community here to see is there other topics from business perspective they are interested in, which we should consider. So, we would like to also hear from others on the call here on what are some of the things you think should be in this workshop. So this is a collective effort, right? So we are also interested in hearing from so many participants who are on call right now. And what are new things which you would like to see in this workshop, which are missing as you see it? Feel free to please share your thoughts. All thoughts
Thanks,
welcome.
Dharmesh. Thank you,
Yeah.
Dharmesh, for bringing that up. That's very important. Yeah.
So I have one thought, which is, in April last year, we had the last business workshop. So what was the state of the chiplet ecosystem across the business world at that time? Exactly 1 year from now, what has changed in terms of open source as well as the proprietary work that's been going on? How has it developed, and is that how things are going to go? The proprietary guys are going to keep doing their own thing, everybody else does their own thing, and at some point there'll be a great revelation of what's the best way of doing it. Just, I don't know, that's just a thought that occurred to me. Sort of the changes in the industry, and can there be any prediction from that? And maybe you can have a
So,
panel with people talking about it.
so Anu, that would be covered in the broad section of state of chiplets. Let's say, call a section called state of chiplets, where we were, where we are, and where we are going, kind of a thing, right?
Yeah.
Yeah,
So,
yeah.
yeah. So
So
state of
I think
open and
state of,
state of
we can change it to maybe state of chiplets, and then open and close is two aspects of it.
I think if I understand,
One
Anu,
maybe. So, sorry,
go
Bapi,
ahead.
go ahead.
Go ahead. Go ahead. We'll do our Ethernet back off.
I think another interesting one, there's a gentleman, I forgot who, from the OSAT world, presented, a few weeks ago, is basically, there is quote unquote the business model, whose responsibility is what. For example, when you have low yield, who pays for it? Is it because of, packaging folks, did not do, the right things, and you ended up with a low yield on the wafers? And is it the OSAT who's going to pay for it? Is it the customer? Is it? And I think he had a proposal around that. I think some of
Yeah,
that
I think it
would
was
be
Michael from JSET.
okay.
Yeah,
Yes.
no, it was a really good presentation. Yeah.
Yeah. But I think that's probably a topic would be good to address. Maybe he can,
So,
yeah.
Tawfiq, very quickly, do you think that in some form or shape gets under a broad umbrella of known good die topic? Because known good die can have a lot of,
yeah.
do you think or no?
No, so Dharmesh, you are right, because non good die, when Roboto put together his modeling, I think he talked about the yield and different party within the non good
Right.
die model, like
Yeah.
SIP
It
builder
is.
versus chiplet builder.
Yeah, I feel it's a subset of it for sure, of the overall, responsibility, quote unquote. But it's not only the die.
From a
It's
business
actually a
perspective,
package.
does it not make sense to think about or have a discussion on the chiplet supply chain, from the design to manufacture of chiplets to the integration on an integrated circuit to a marketplace?
Yeah, I think that
Yeah,
makes sense. I just added value chain as part of the topic at the bottom. So
Okay.
that's absolutely a good topic to have. I think it could be somehow rolled into the state of the chiplet. One of the topics there could be supply chain or value chain readiness.
I will expand this to expand Taufik's comment to include RACI, right? The responsibility for the supply chain in order to make this chiplet integration successful.
So we can add things in the yield, right? In the KGD. So yield is one which I think Tawfiq mentioned. Then responsibilities. Good points. Good points. I think we can add and expand. Any others who want to chime in?
And
Just
does
a
it
quick question. Is the testing and probing part of the non-good die as well?
yes, testing and probing. Yes, you're right.
Okay, thanks.
Uh, Another feedback, again, we are also looking into the mechanics, but also from a representation of the ecosystem from a company standpoint, does that look good? So we right now we have OpenHBI, then within the bow we have these two, and then we will see if there is any other open, chiplet or proprietary interface. And with the proprietary, we have some of these company listed. Any other, and then from
Are
Foundry,
there any open HBI IP providers that have gone public?
not that I'm aware of.
I think something like that we can definitely have.
I'm sorry, not very open, guys. I think you should drop the
No,
open.
I think OpenHBI is an open spec contributed to OCP, so that is open, right? So
Yeah.
when we say OpenHBI, it is open because the spec is contributed into OCP, accepted, and all of that. We have seen it, and then under state of chiplets, we can kind of discuss in workshop. So OpenHBI spec got released. What next is going to happen, and then we can bring OpenHBI folks to give a presentation there, right?
But if somebody is designing a device and wants to find somebody that has open API IP, how do I do that? Right? Other than going around asking everybody.
So you have access to OpenHBI spec today, which you can
Yeah,
use.
but I know. But if I'm trying to design a device and I'm not a PI person or PI company, how do I find providers if nobody's being public about it?
I think you can have some conversations under NDA, right? So you can go. If I were you, one of the
Yeah,
steps I
so
would take,
you're on your own. Basically, you're on your own. Go find them yourself. Have fun.
well, you are looking for an IP provider. That would always be the case, even for other open projects, right? Because as soon as you are looking for an IP provider, you want to make sure that there's a business relationship, and a lot of that doesn't get conducted in open. Open doesn't mean that business models are open either, right? Open means that there are common standards which people have access to relatively easily instead of developing everything from scratch.
Hey guys, let's I think this is a good standing topic. So Ravi, can we hit it next week too for about 15 minutes?
Yeah, I like that idea because rather than solving everything today, I think this
Yeah.
is a good start. And I have put this in the chat. And if you have any suggestion, please feel free to add in the bottom so that we can see. And if you can also put your name so that we know who to reach.
Yeah, just one last offer for people to consider. Maybe we can circle back on it next week. This is Cliff from OCP. And since this is a business-oriented workshop, if we wanted to potentially have a keynote from an analyst to give a market overview, it's something that I could see about arranging.
Okay, I like that idea. So maybe.
And can we confirm, is this in person or virtual, this workshop?
We have to decide. So right now I have everything open, in-person, hybrid, remote. I
Okay,
think we are not there yet to make that call yet.
thank you.
Okay, I'll stop
And
sharing.
Ravi,
So
Yeah,
go
and
ahead.
Ravi, the only thing which maybe we can tweak is the time which we show as April, May. I know that OCP is conducting series of workshops for all the projects
Mhm.
for 2 weeks, right? So it would be best if we kind of merge it with that event, because that
When is
event will
that?
be, yeah, I think it is end of May, beginning June. And we should bring Archana here to give us an update on that, because she had shared it in some other forum. And they are planning it. Foundation has not finalized it, but they are going to have a big marketing push to uh, publicize all of these workshops happening. And I think we can be part of that.
I
That's my
like that.
only.
Yeah, no, I like that. I think rather than doing something of our own, I think we should merge with the bigger OCP event.
Right, we'll get more marketing easily, and all of that would be easily done.
Okay. All right, I'll stop sharing now, Bapi.
All right, so we'll pick it up next week. I think it's a good. So I'm going to give it to Shahab. And hey, Shahab, I think this is going to keep us occupied for a while. So you don't need to finish in the 40 minutes. Let the discussion go, and we can continue the discussion next week too. So don't try to sort of rush it through the 9 a.m. deadline.
Okay, I will
Take all the
try
time you want. We can pick it up next week as well.
Okay, sure. Thank you, Bapi. Well, welcome everyone. I think today we're supposed to talk about the optical I/O and co-package optics. I have to apologize at the beginning. I totally had it in my calendar as a next week, wrong date. And thank you, Bapi, that you remind me last night. That's why I think most of my slides are basically copy paste from here and there, and maybe not in the basically perfect shape that I should present it. But anyway, here we are, and we'd like actually to talk about the. Do you guys see my screen, by the way?
We can
Yes,
see it.
Yeah.
we
We're
see
going
it.
to talk about the co-package optics, which we call it CPO, or optical input output, or optical I/O as a OIO. Basically, that in one sentence, if I want to see basically state the difference and between these two terminology, but both of them are kind of new, especially optical I/O, by the way, is that the co-package optics is for switch networks and optical I/O is for chip-to-chip communication. But my whole basically talk is going to be the difference between these two, the motivation behind it, and what's going to be in the future. Let's start with the optical I/O and see why do we need it and where we can actually fit it. This is here we are basically at 2022, where the transistor scaling is almost saturated. No more increasing clock frequency, power per package is kind of limited. Increasing the number of cores is not helping us to get to the higher performance. And at the right side also, you see that we always want to increase the performance, and the solution might be actually in a different architecture, like as heterogeneous architecture, by adding more CPUs together in the past. And now we are actually considering having GPU and CPU together, or add a couple of accelerator to it. But eventually in future, we really like to have a kind of wide architecture, heterogeneous architecture, that we do have a pool of memory that can be shared between the different resources of the processing unit. And if you want to get there, let's see what are our limitations there and how we can solve it. The first limitation that we can see is the power, basically. The left graph at the x-axis is the years, the y-axis is the power, and the green actually line shows that the total power per package for a chip, and the orange line actually shows how much power do we need to off-chip the data, basically go outside the data, send the data outside the chip. And clearly you see that we are actually getting to the point that either these two are equal, or even we are surpassing that power from the off-chip I/O. And this is not a sustainable solution. I mean, we cannot actually burn more power on just transmitting data and have a less power basically for compute.
So,
Then,
Shahab,
yes.
quick question. So this total power per package does not include the I/O driver power. Is that what you're saying?
Correct.
Okay, thank you.
By the way, there are a little bit of different definition here, but that total power per chip could be actually a kind of limitation of the package as well. Then you can look at it as, oh, we are basically getting to the limit of the package as well.
Okay.
There are two limitation factors from there. One is actually how much package can dissipate, and the other one is how much we need for processing. And if we look at the basically I/O at the right side, we do see actually a good electrical I/Os span over in-package and on-board. And historically, optical was used for off-board, which is the off of the PCB for a long haul. The x-axis here is again the distance, and the y-axis is a bandwidth density times energy efficiency. And if for any reason, if we can, with any technique that we can, if we bring optical to the left domain from the off-board to the on-board, and maybe in package in future, then we're gonna actually hit the kind of orange area that I mentioned over there. And that's basically the advantage of the optical I/O to get there. Then this is a good motivation to go for optics.
Hey, Ardalan.
Yes.
So, at what distance do you think, like how long those interconnects have to be for optics to win over electrical?
That's the perfect question. I think this is my next slide is gonna actually show you.
Hey,
Yeah.
Shahab, if you just go back to the previous slide for a second, what is the definition difference between off-board, on-board, and in-package?
In-package means in-package, on-board means on one PCB, off-board means basically off of the PCB. That if you look at it, for example, you can see it from the distance. This is per meter. If you are going more than 1 meter, basically you need to get out of the PCB, large chassis, and then go somewhere else. And if you are less,
going from the rack to something a long distance.
Yeah, but as long as you get off of basically a daughter card or mother card PCB, that's why we call it onboard and offboard.
So is the thing where the optics is terminated inside the package could be any one of these things then, depending on what the distance is. So CPO is an orthogonal definition where optics is terminated in the package is in a definition orthogonal to in-package onboard versus offboard.
Not really, because this is a kind of co-package optics as well, but this is how we can actually get to the optical domain. If we look at this slide, I think this is actually shows in more details what I'm talking about. And this is basically the optical interconnect landscape. The green area that you can see on the left is the copper. The blue area is the optical. The x-axis is actually the distance. And the left is the link bandwidth that we need, and also in terms of the year where we are. Historically, you see that we started at 100 kilometers for a long haul, and we are keep pushing it. Basically, we are at 400G, 800G, moving towards 1.6. Everything is going to be optics. We didn't have any problem for more than 100 kilometers because copper was not there. But when we are getting actually to the data center instead of the telecom, still we are fully almost optical here, and we are kind of one generation behind the long haul, or more than 10 kilometers, but we are getting there. We used to be basically those orange line that you see, it's a VCSEL, which is a cheaper version of the laser and silicon, basically the optical communication. And now we are getting to the silicon photonics, and again we are going through basically the path of 100, 200, and 800G, and 1.C, 3.2T. We think that this is actually the area that co-package optics is going to happen. If we go again basically a AI and HPC rack interconnect, which is less than a 10 meter, again we see the same thing. People have started actually using VCSEL, and now they are talking about the 800G, 1.6T, and again there should be a good solution or a good option to go co-package optics or move the optics inside the chip. And again, if we go again back to the 10 centimeters or even less than 1 centimeters, we do see the great need here, which is around 1 terabit per second per millimeter. I think this is the norm that we are using these days. To pass that range, there is still some debate that where we should actually go to the optics, but sooner or later we're gonna get there. And that's where the optical I/O or co-packaged optics is going to actually enter to the market. Did I answer your question, Louis?
Kind of, because I think, you know, the trade-off is you're going to lose quite a bit of power in the conversion. And yeah, from optical to electrical. So 1 millimeter, I kind of doubt. There was, you know, I mean, it answers me certainly. Certainly, I have no question 1 meter and above. Okay, and maybe I thought in my mind 1 meter and below. I don't have a question, but that gray area there, you know, I don't know. I don't know if you'll ever get to a chiplet, you know, like you're talking about very few millimeter interconnection, if optics would be, you know, would be more power efficient.
Yeah, we're gonna have some example that I can share, and some of them I cannot. But these are the area that we're gonna get, because we cannot actually achieve this 10 terabit per second per millimeter with electrical for sure. We got almost stuck at 112 gig, and there is no.
But you believe you can achieve it with optics?
I'm sorry.
But you believe you can achieve it with optics?
Yeah, that's the only solution that we have. Maybe there are some activities around 224 gig electrical. We may have something at 224, but again, clearly at 400 electrical, we don't see it very clearly that we can actually compensate that much of the loss. Basically, why do we need that? Is one of the main reason is actually because we really like actually to go to the disaggregation and future architecture, as I mentioned. For example, at the left side, you see the conventional rack style, which has a GPU, CPU, solid state drive, memory, and optical. But the new basically proposal for this aggregated rack is to separate all this units, basically have all the CPU together, GPU together, memories, power, solid state memories, and optics, and basically create a flexible and dynamic resource allocation for all these racks. These are something that people are thinking, and without optics, most probably we cannot get there. For example, without optics, we cannot provide that much of bandwidth between this pool of the memory and pool of the, for example, CPU.
I don't disagree, but do you need the optics all the way into the chip to communicate?
How we can actually get that bandwidth without optics? That's the question. That's the main motivation behind optical I/O, because clearly we cannot actually get to this kind of bandwidth with electrical and the power of it. You saw how much power we are burning right now.
Yeah.
We got limits here.
Shahab, does this optical power account for the laser power also?
Of course it has to be. But
okay.
There are different solutions. For example, you can move the laser outside the package, which is, we call it internal and external laser. And if you move the laser outside, then you don't need to burn or account it for the in package at least.
And then the cooling for that thermal dissipation is a whole different mechanism.
It's going to be much easier because you can actually have it at not close to the GPU or CPU.
Okay, and one more question. So you're saying that for communication on the picture on the right side, the disaggregated rack, what you're saying is to communicate between these slices which are sitting vertically on top of each other, you'd go electrical to optical for the communication.
Correct, and people may actually consider between the CPU and GPU to GPU also be optical as well.
That's what I'm asking.
That's a lot of conversion. Yeah. Okay. Thanks.
Shab, just brief question. Is Alex from India, just joined first time the consortium meeting today. And so for disaggregated solution that you have, it implies that at some point you'll need some optical conversions to the switch. I mean, you'll need some switch solution that would either accept the optical input or convert it, or I mean, there would be some switch on the path here.
Of course you need to. Yeah. 100%.
By the way,
the potential limitation of the disaggregated rack is the latency, right? So.
Yeah, but because I was gonna comment. I don't think the picture to the right is completely right. Because I think what you'll see is a combination of the left and the right because of the latency issue that the gentleman just mentioned. For example, you might have still a very small footprint of DRAMs or memory on the CPU in the package, or even smaller, or something on the board. But the bulk would be like you're showing here. So I don't think it'll be entirely 100% disaggregated because of the latency issue. Basically, you still need some memory that's going to be very close to your computing, computing engine.
Why it has to be so close? That's the question.
Well, because of performance, latency, right?
Not because of the latency.
Absolutely. I've done presentations on disaggregation and trends in memory. But that's absolutely a valid point. You need the memory really close. I mean, HBM is as close as you can get, right?
Yeah. Okay. Hold on to that, because all of you guys are assuming you cannot provide that bandwidth. That's why you're bringing it so closer. If I provide you higher bandwidth density, why do you want it to be so close?
No, you need latency as well. So what you're saying makes sense. We need disaggregation for sure, but we need it in a much smaller level. We need it in a OAM module size level, and then you would connect them correctly with optical. You stay electrical whilst electrical is less power, but when optical is less power and less cost, then you would transition to optical. So the story is the same as it's always been. But we need to miniaturize the system. That's what people don't understand. They live in this 19-inch rack, and you got to remember, 19-inch racks are about 2 meters tall, and we're a nanosecond per foot. So and every nanosecond is a prisoner. When you talk to a guy that's trying to connect the memory, certainly in CPU type with things like caches, level 1 cache is 1 clock cycle at 3 or 4 gig. Level 2 cache is 1 to 5 nanoseconds. Level 3 cache is 5 to 10 nanoseconds, and main memory is of the order of 45 nanoseconds right now. And so that's a huge, massive leap. If latency wasn't a problem, why not just go straight from level 1 straight to your memory? And it's the same argument with CXL. We're going to much deeper depth. So it's the latency. The bandwidth is great, but it's the latency that's a problem.
Yeah, but you can solve that. For example, you can have an HBM on the package, like you said, but I no longer need DRAM on the board. I could do like that picture on the right. So for the latency, you have the HBM that solves that for you. For capacity, on the other hand, you could disaggregate. So I think it's going to be really a combination. The memory subsystem is not, I don't know, at least it's not going to be either or. It's going to be a combination of both. You're going to have memory because the latency basically very, very close to you. But all that DRAM on the board, I probably could get rid of it, basically. And I think you could come with a reasonably cost-effective system whereby the disaggregation of the DRAM could make up for the additional cost of the HBM, basically. But you see what I mean? Does that make sense, folks? So,
right. So the latency comes in 2 parts. One is the distance, right? Time of flight. And the second part is the conversion to optical and the EO and the OE. The conversion actually introduced that extra latency as well. So optical is definitely nice, but still lots of things need to be taken into
how much is the latency for existing 112 gig solution? I'm just asking you guys, since you just brought up the latency. By the way, I'm not the computer architecture. I'm mainly circuit developer, but out of curiosity, when we talk about latency,
it all depends on whether you have FEC or if you have FEC, it's pretty large.
Do we have a solution for 112 gig that does not affect?
Sure.
No, not today.
Electrical currently, for instance, like a memory connection on board, we're within like a tens of nanoseconds. But with optical, it will be much higher, right? So the conversion itself takes tens nanoseconds as well.
Let's talk about the numbers.
Wait, guys. we're sort of getting sidetracked. I think, you know, disaggregated rack is just a motivation. I think at least for this talk, we're sort of interested in the, you know, what is the state of the art in the optical phi and the conversion and everything else. So I like this discussion, and maybe we can sort of resume whether we are going to have disaggregation
Or not.
Or not as an orthogonal discussion.
Yeah, I agree.
Yeah, but just because there was a lot of discussion around latency, I basically decided to stay quiet and let people figure it out. But latency that you get out of 112 gig, any kind of basically a little bit protocols that we do have existing today is going to be around 15 to 20 nanosecond delay, because you cannot actually achieve a good bit error rate without FEC. It's impossible actually to have PAM4 without FEC. And the electric part is around less than 5 nanosecond. I mean, the majority of the problem of the latency that we think that is going to be on the electric side is going to be because we have to convert it to PAM4, and we need to have a very heavy FEC over there. When we put the numbers, it's not just easy to say, okay, the conversion is going to take so much of the latency. No, actually, the error correction is actually taking more of the time. And if I come with a solution that does not need FEC, which could be optical, then I'm going to save a lot about the latency. By the way, again, I might be 100% wrong. I'm not a computer architect, and I just brought it up why people are so excited about the optical I/O, because they like actually to see these things. And at the right side also, you see a system concept which they call a GPU tray. It was presented by Bill Daly at GTC China December 2020. And
Hey,
that's
wait, Shahab.
Yeah.
This what if you take this picture and go back 2 slides, the one with onboard, offboard.
Yeah.
Is the link between those disaggregated boards, is it going to be considered onboard or offboard in this definition in terms of distance?
It's going to be on board basically. See
Because it's within the same rack, even though it's just marginally off the board.
Exactly. This area. I don't know if you see my mouse or not. Maybe I change it to the laser pointer. This is the area.
Now I do. Okay.
Because we need to pass basically 1 terabit per second per millimeter. Back to the discussion that we had. Yes, of course, these are, for example, let's consider they are ampere 100 and they have, for example, 6 HBM. Can I put 8 HBM there? No way. Can this GPU access the other HBM from another GPU? No way. How can these two GPU can communicate to each other if I cannot basically provide them the higher bandwidth solution?
But the link is in that graph from two slides ago. It's is considered onboard distance between the boards.
Yes.
Okay, thank you.
That's not confusing me. Shahab, in your picture, where does optics start? Where do you start? The optics I/O. Where? I'm sorry.
In the NVIDIA picture or in my picture?
In your picture, in the middle picture.
Yeah, in the middle. Right now, the idea is actually the easiest place that you can actually have it is between basically the gray plated, the daughter boards. But there might be actually in future, this is the next level that people are talking about, is going to be the CPU to CPU and GPU to GPU. And for example, memory, all this SSD goes back. I mean, I didn't put picture here, but Samsung has something that goes from the SysX directly to it from the SSD to PCIe, for example. That could be a solution here, for example.
That's a good discussion point. I guess it boils down to the picojoules per bit. So what picojoules per bit does this all make sense for a connection?
I think the target for optical I/O is less than 1 picojoule per bit.
Yeah, but in this situation, if the optics was on the gray pieces, then you've got all the electrical power getting from the processors or SSDs or the memory to the optical conversion before the communication. And then if you're going to do a torus, then fine. But what happens when you need a switch? Is this going to have an optical switch? Is it going to have to convert back to electrical for switching? And all of that adds to your picojoules. You can't just say the picojoules of the conversion. It's the picojoules of the whole system, end to end. Now, if you put the optics buried in the processor directly, and it's less than an electrical driver, the argument makes a lot of sense. And we have pure optical switches, so it's zero power. Now, we have optical circuit switches today, but we don't have optical packet switches. So there's a lot of system level aspects you need to think about here. Now, I can see why it works for AMD, and I can see why it works with HBM, what with NVIDIA, and what they're doing there for their specific use case. Fantastic. But all they have is GPUs to GPUs, right, on their one. They don't have all of these SSDs and all the rest of it. They'll connect more traditionally with the rest of it. This is all their own NVLink fabric connection they're talking about. And they can do it because it's very, they own everything. So I think it's a bit too simplistic. I see the vision and where it's going to go, and we are going to get there for sure. Co-packaged optics and all of that, but there is so much more we can do today. And we've been saying it, we're going to go optical for 20 years. And look at back at 2000, all the money poured into optical then. So yes, we are, and it makes sense, and we can certainly improve organically on optical today. If only we took silicon photonics, which is much lower power, if we can get it to work in a cable, in an active cable, suddenly this becomes, from a systems architecture perspective, it becomes much more logical. And we can get down to a picojoule per bit, or near enough, 1 to 2 picojoules per bit, with this disaggregation you're showing at a much denser modular level. And then suddenly we're at a picojoule per bit. Now, at the moment, we're at 5 to 10 picojoules per bit because we think about everything in a server 19-inch rack chassis perspective, which means you need 5 to 10 picojoules per bit. Even with all the innovations we're doing with PAM and all the rest of it, as the speeds go up, we still need 5 to 10 picojoules per bit in the box, and we still need 20 picojoules per bit to go up and down the rack. Whereas you guys are doing wonderful things at half a picojoule per bit and less if we go on package, but it cost me $10 million to build a package with 5 chiplets on it. But we can do something. And this is what we're trying to do in OCP HPC, in the OCP HPC work group, is let's crunch a 19-inch rack down to the size of an OAM module. And let's do the disaggregation you're talking about there and stay electrical. And then when we come off of the module, then we can go to neighboring modules with electrical cables, which are 5 to 10 times better, even in the 34 gauge ones, and lots cheaper than optical. And then when we actually go to a distance where the electrical gives up at 112 gig or whatever the speed is, we then go to the optical to go. So your arguments are right. It's just a scale. We shrunk silicon for 30 years. The 19-inch rack is 100 years old this year. 1922 was when AT&T invented a 19-inch rack, and we're still partitioning everything like this. And disaggregation is domain-specific architectures means you can plug things together to your specific application needs. So the diagram you have here is correct, but it's at a 19-inch rack scale when it could be an OEM module scale. And so I can save 20 picojoules per bit, or 19, by going from a rack scale disaggregation down to a module scale disaggregation. I can get to a picojoule per bit, which is where the optics is right now, but I don't lose anything else. So it's all, we need to crunch the system. There's so much opportunity for us to crunch the system.
Well, then let's do it.
Nobody can see it.
But then let's do it. Nobody's actually stopping you. I mean,
oh no, I'm trying to do it. I'm doing OCP HPC. We're actually making great progress, except for I've got no money. Intel, Microsoft, Facebook, everybody's throwing billions of dollars at all this other stuff, and no one's, we're a bunch of crazy dudes in the corner as far as everybody's concerned. We're systems engineers.
Yeah, then
so
if you don't mind, let me go through the talk, and then if you have something.
Sorry, you just you're just pressing a button.
If you don't mind, you can schedule one talk for Alan, because it looks like he has more things to say rather than me. That's not my position here to defend basically disaggregation or not. I'm just saying disaggregation is one of the main force and motivation behind optical I/O. That's the message that I'm delivering.
Yeah, and I agree with that. I support that.
Bapi, guys, can I make a quick suggestion? Bapi, you're organizing the Grade 5 debate. Do you think we can have also a debate on this topic with participants on both sides of the debate? I think it's a very interesting discussion, and we should have a much deeper discussion rather than it as a sidebar for one of the slides Shahab is presenting. Thoughts? Tawfiq can be on one side. I think others can be on one side. Shahab can be on the other side, and we can
I
all
can't
join
actually.
forces
I'm
in
not a
various
computer
areas.
architect. That's the whole point that I'm trying to say.
Shahab was wondering why he's paying such a huge tax for borrowing a couple of slides.
No, I'm just saying it why people are so excited about the optical I/O, and that's this is the message that I'm delivering.
No,
What
jokes aside, yes, it is.
other
It's worth
thing
having a
is
debate. Alan's been on this
if
thread.
people think disaggregation is not going to happen or we don't need chip-to-chip communication at optics, that's their own view, but I cannot defend it in terms of the architecture. I'm the I/O designer, and I can see why this is actually important. And the whole topic of today was what is the optical I/O and what is the co-package optics. At least we find out these two terminology correctly and see where we can actually fit by providing some standard around it. I'm not defending disaggregation, although I have my own opinion, but I'm not the expert on it to basically
The disaggregation is right. It's just a scale that the disaggregation. Everything you're saying is right. It's just we need to look at it from a more of a holistic perspective, and there are other knobs we can push. Is my point. This diagram is great. It's just in the context of the 19-inch rack is where it's fundamentally flawed.
Okay, then
yeah, I agree. Actually, you got so many comments because the topic is so interesting. So go ahead, don't be nervous. I think people just interested in the topic.
Then even I scared actually go to the second slide, because in the second slide I'm gonna show why that was the co-package optics, and this is how we looked like in 2022 for providing 51T switch, which is actually the motivation behind co-package optics. Again, please look at the terminology. Co-package optics is for switch, and the optical I/O is for mainly die-to-die communication. And this is basically kind of Moore's law for network switch. We see that every 2 years we are actually increasing the capacity. And this year at 2020, we are expecting a 51.2T switch, terabit switch. And back to the electric side, most probably this is going to be in 5 nanometer. Then we need actually to send 51.T terabyte data out of this chip. And how we can do that? We need actually at least 100 gigabit per second CDRs or SerDes. Okay, just physically imagine how many of those we have to put around the single chip and how the yield is going to be. Then what's going to be the solution if we just want to go in 2 years to 100 terabit per switches? Then can we actually fit 1,100 gig electrical? Or we have to go at the best scenario, push the electrical, change the package, change the PCB to get to the 200 gig SerDes electrical. Still, we have to fit 500 of them around here. This is the motivation behind co-package optics from the smaller market, which is the switch network, compared to the disaggregation and data center that I was mentioning. But how we got there, it's so clear and obvious. Why do we need it? I mean, I'm trying to basically show the progress of the evolving basically to get to the optical chiplet. People may not agree with me. This is basically the basically a daughter card here. This is our, at the left side we see our ASIC. At the right side we do see our optical module or optical connection. Historically we put this one at the back of the rack, and the CDR or SerDes is going to stay at the left side in the ASIC. And we have to basically send all the way the data directly to the optical. By the way, the orange triangle means where the laser source is, and the yellow star means where the CDR is. Okay, we find out, okay, this distance is too long for the higher speed. We cannot actually have the CDR or SerDes only at the ASIC. In the next version, we add a SerDes to the optical engine. Now we can actually compensate more loss around here and go higher speed. Another alternative was to have something in the middle of the PCB, basically to go from this side all the way to middle, get retime, clean the data, kill the jitter, and then send it again to the laser module. Now people are
that's just the retimer solution, right?
correct.
Yeah.
And then people actually decided to bring this back and get it more closer to the ASIC instead of being in the back of the chip and go this distance over optics. That actually save a little bit of the power by going shorter distance in electronics. I mean, these are again, people may actually right now argue no, electrical is better than optics, but this is a clear path that we went through. And to justify, yes.
So, yes, sorry, you finished the bottom, and then I'll ask you a question.
At the bottom, we are actually trying to move this one in the package, which we call it co-package optics or chiplet for optical. And then we may or may not have a CDR at both of them. This is something that at the right side you can see. And because we are actually integrating this one to the package, looks like the better solution is actually to move it outside, the laser source be actually outside. There are some people that they are basically, for example, Intel demoing a good laser inside this package, but majority of the people right now are thinking to decouple the thermal laser from the large processor to move it outside. Yes, Bob.
Two questions. One, does the bandwidth efficiency stay roughly constant? Beachfront bandwidth efficiency stay roughly constant across all these solutions?
There is no definition of the bandwidth density, or as we basically explain it, we define it as maybe in the die-to-die communication, because this is actually going through the motherboard or PCB. Basically, it has to get off of the chip and then goes here. And
right.
For example, the top solution is around 10 gigabit per second, and the pitch is kind of constant for all of them. If we assume,
constant, right?
If the pitch is constant, then each of the solution, as we keep going from the top to the light, the top to the bottom, is going to improve the power efficiency and increase the speed as well. Then if we assume that we have an increase in the speed, for sure, bandwidth density is going to increase, because the limitation over here is basically the routing, which is the same for all of them.
Okay.
Shah,
Yes.
one question is, so what we're calling as optical chiplet, it's an optical engine with multiple die. It's a package. It's not like it's just a silicon.
This is actually the right picture that I haven't present. Then we have a different solution here. I capture 4 of them here. One of the option is the gray area is going to be the package substrate. These are all co-packaged solution. Then we could have actually XSR or retimer. By the way, this is specifically I mentioned, I present this slide in 2020, but some wording has been changed, but this is my next 2 slide that why the name got changed. But this could actually be 3 different chips, could be optical chip, could be a TIA and driver chip, and could be a retimer or XSR here. You may actually remove this XSR and put some stronger XSR at the left side in the second option and just drive it, again 2 chips. Some people may actually come and combine this optical, which is photodetector and modulator, with the TIA and driver, all of them in one die, and then drive it. Or somebody may actually combine everything, the XSR, TIA, driver, optics, everything together and provide a monolithic solution. Although in the optical process or silicon photonics process, because they are not on the advanced node, then it's going to be super hard actually to provide it with 100 gig or something like that. Then there is a preference of the people that they go to the parallel bus here instead of going with the XSR.
So Shahab, this is an excellent slide, and I love this. And look at all of that integration you're doing. And if you stare at your own diagram long enough, where is all the work being done? It's all being done at the photonics end on the right-hand side. And like you say, it's only the last one where you move from XSR or this XSR plus. Now XSR has a reach of about 70 millimeters or more. And so why not make that all those ones on the right pluggable And actually, if they're low enough power, put them into the tiny cable connector. And then
Sorry, I got a little bit distracted. You said what's the distance for XSR?
XSR is, according to Analog X in that spreadsheet that we did in ODSA, was 70 millimeters.
It's 50 millimeters, 50.
50, okay, 50, 70. I mean, maybe Analog X could make it reach a bit further.
Analog X never had the XSR, just because we bring up the name. I just want to correct.
Well, no, well, my point is you can put a connector there between the two, and suddenly it becomes far easier, far cheaper to make this progress, and you don't have to spend $10 million every time you upgrade the right-hand side. You just throw a new cable in. So why don't we do that? Why do we have to go to the nth degree of co-packaged everything? Why not connect it with and have the intelligence in a cable connector? If it's so low power, because silicon photonics is so much lower power.
Correct. Which cable we are talking about? We are talking about this picture, the top one.
Oh, no, the first three. The right-hand side. Put the right-hand side of the red line.
Okay.
Right-hand side of the red line of each of these diagrams. Put that into the cable connector.
These are all in package. I don't understand what you mean.
I know, that's what I'm saying. But put that into the cable.
Going back to this model, going to the left top. The one before going to
effectively yes, but effectively yes. I mean that's what you're doing. Do all the work.
How much power you're gonna burn when you go electrically from here to here?
The same, because it's XSR. If you make that distance short enough, it's XSR.
No, it's not the same. Then you need the LR here, and you have to burn 7 picojoules.
No. That's what I'm saying. If you bring it close enough together, 50 millimeters to your point, it's XSR. It's the same power, but it's
so
still.
Alan, are you suggesting that it's active cable? So you're moving your optical pieces into the cable, into a smart cable?
Yes, and because the beauty of silicon photonics is so much lower power than the QDD, QSFP photonics, you can put it into the EDSFF connector, the SSD modules that go in, into an E3.S connector, or which the NIC 3.0 goes in. Suddenly you can put it all in, and then the innovations of the right-hand side on all of the integration of the photonics as you progress can be done in a cheap cable, not have to spend $10 million to repackage it each time inside a freaking $10 million package. And XSR is 50 millimeters, so you can put a connector in it. If you bring the two together and don't do it in a 19-inch rack. You need long reach in a 19-inch rack because it's a freaking long way away between the QDD and the processor. But if you could do it, if you could crunch it down at the system level into something the size of an OAM module, you can do XSR and you can make it pluggable. And
no, you
cannot.
You're making it. You don't see this one. This is actually over the PCB. This is over PCB of the package. These are two. These are the two different material with the two different reflection.
I know all of that. So come to the watch the OCP.
You know about that. You cannot put XSR here.
Yes, you can. I've done it. I've done the analysis.
Okay,
I've done the analysis with IBM. Did the simulation of the channel.
Okay, IBM doesn't exist in this roadmap, and this is a clear message that why their solution is not working, and they are not in this business. But if you do have a solution right now for 51.2T or 100T that only works with XSR, and
so you're talking about the sheer number of channels now. So
that you can make.
Hey guys, I didn't take any notes. It's 9 a.m. Shahab, clearly there's like a huge amount of interest. Okay, either we'll have you. I got to figure it out. We've got the link. This is what I thought.
I don't mean to derail it. I just
no worries. No worries. The only person to blame here today is Ravi Agarwal. Nobody else is responsible. But that's an orthogonal thing.
Yeah. By the way, I
looks like we ran out of another round. Very interesting subject.
This is a fantastic subject. So Shahab, let me work out the schedule and but we will stop here because this is exactly what I hoped would happen. So if you can please hold these slides, we'll pick it up next week. then we will. What I'm thinking is we'll move the grade 5 debate back and go through the link layer and the optical. Do the optical next week, and we'll figure it out.
Yeah, it would
We're
be
not
great to
actually here,
continue here.
but it's 9
Thanks.
a.m., so we're losing people, and this is too important a debate to sort of lose people on.
Sure, I can stop it.
Okay, so we'll pick up next week. Ravi, it's all yours.
Thanks, Bapi. So we'll transition into chiplet business log group, right?
Yes, we're transiting. We didn't notice the time. This is a really exciting debate, exciting presentation. Thanks, Shahab.
Thank you.
Yes,
It
thanks,
was
Shahab.
great.
Okay, thank you all. Bye.
Thanks, everyone.
Hello, everyone. So probably we'll start in a minute for chiplet business workshop, not workshop, work group. So as the agenda, I have on a few topics in mind today. One is we want to finish our white paper, which we've been working from the last couple of weeks. Let me share my screen. Can you see my screen? Thank you. So I think there were comment on the thermal model as well as on this part, and I think Roberto and both Yin already cleaned their part. So let me just poll who all we have on the call.
Hey, Ravi, it's Anu, but I have to leave at 9:30.
Yeah, I think it will be a short meeting, Anu, I'm pretty sure,
Okay, thanks.
because there are not that many people. So I think we can, so in my mind, everything has been added into this paper, and I think I'll wait for Dharmesh to join. I think this is good to go now, because otherwise we will keep working on it and it
Yep,
will never be done.
I agree. I think we've spent enough cycles on it, so I
Yeah,
think I'm done.
yeah, I think we should just call the day and then
Submit. Yeah, yep.
yeah. Otherwise it will
We can
be,
keep tweaking the heck out of it otherwise. Yeah,
yeah, and I don't think that's a good use of any one of our time,
I agree.
somehow. Oh, we have a different text size. Okay, looks like my internet is behaving weirdly.
I think it's preparing for the weekend.
I know, long weekend. Do you have any plans?
Yeah, don't say long weekend to me because yet again, I don't get a long weekend.
Oh man, I'm so
I
sorry.
know. Yes. Yeah, you
That's
should feel very sorry for me. I feel very sorry for myself, believe me.
yeah, I know. Especially when you hear a lot of people talk about their
Everybody tells me about long weekends, and I'm like, huh? Huh. I never heard of that one.
what are you guys talking? Is there
Yeah,
something wrong?
yeah, yeah. But I'm gonna
Oh,
take most of Monday off anyway. I just have 2 meetings, so I can't stand it.
yeah, I know, I know. So, Anu, I think since nobody is on the call besides you
Hey,
and me,
Ravi,
yeah. Hey,
this is
Kevin.
Kevin.
Oh,
Hey, can we just go
because
back to the title page a little bit? I just have one comment.
yes, tell me. And if anyone's name is missing, feel free to tell me, and I'm happy to add. I have no problem.
Can we change the title, Developing an Open Marketplace for Chiplets, Challenges and Opportunities? It just reads weird. It means we're creating
Okay.
a chiplets for challenges and opportunities.
Okay. So say again, developing an open marketplace for chiplet.
Why don't we call it Developing an Open Chiplet Marketplace, and then challenges and opportunities.
I like that. Chiplet, open chiplet marketplace.
And get rid of the for and just put challenges and opportunities. I think that more reflects what we're trying to.
I like that. Something like this, right?
Yeah.
Why this is 14. Wow. There is something weird here because the C is see D and C are something interesting, right? Anyway, I will not bore anyone and take precious time. So why don't we call the day and then I'll work with Archana in OCP and with Dharmesh. We'll publish this, and then some of the other topic I had in mind is Anu, since you are here, maybe we should be in future meeting thinking about what are you guys thinking as a next step for cost model?
Yeah, no, sure. We can give you an update on where things are.
Yeah,
Yeah, not a problem, because we are continuously working on it and improving it, and
yeah,
trying to actually publish it in the IEEE Explore,
sure.
because that gets the best audience. So we're trying to write up our algorithms. And then the second piece is Mudassir has someone in Google who's helping us write Python code, so that instead of just spreadsheet based, you can actually, that's phase 2, is Python based, input parameters, and it spits out your results, and it does sensitivity analysis for a few parameters which we believe,
So yeah, so I think maybe it will be a good idea to have
yeah,
you
we'll give an
and
update. Yeah,
yeah, give an update and then see where it is heading.
sure,
So
not a problem.
Dharmesh, we were about to call off the meeting because there are not many people besides Anu and Kevin, and I think it's now you. But
Okay.
Actually, Bill Chen is there, Rishi is there.
but I don't know if they are active in the meeting or they some because when I
So
asked
I
who
think
all are,
what we can do, Ravi, is do a quick final, pass through of the white paper you're showing
so
for
so
everyone
we
on the.
briefly looked at it, the Dharmesh, before you joined. So we already looked at it in terms of what Roberto and what Yin added, and I think it looks clean now.
So we should, uh, I think we should kind of accept all of those words which we have red underline and then generate a PDF. And then I would like to start the process of submitting this to the incubation committee
Okay.
for, further approval and release to OCP. I
Yeah.
think,
So all the
yeah.
changes has been accepted, Dharmesh.
Yeah, no, what I'm talking about is I see red lines under names and things like, you see that, right? Everywhere?
Oh, I
Workspace.
see. So when
I
we
think,
convert it to PDF, do they show up? I doubt.
I don't know. Can we try? Maybe we can try. If he doesn't show up, then we are good. Then we are ready to wrap it up.
Let me do it, and I'll give you a clean one without any red
And
thing.
then I will start the process of getting this submitted into IC, and hopefully in next 1 month it not only gets published, but we share it with on Friday call, 8 a.m. call. One of you guys or whoever wants to quickly present this, so that all this discussion about known good die and things which happened, people can see that there has been work done in the white paper already covering a lot of the things which people talk about, but they are not aware that business group is working on it.
Yeah, no, I like that idea. I think we should do that. Okay, I'll take care of that, the cleaning, and give you a PDF, and then you can take it from there.
Perfect. So I
All
don't
right.
have anything else for today, so maybe we can stop.
Yeah. Thanks, everyone. I want to give time back and enjoy your weekend. And Anu, I cannot say have a long weekend. Enjoy it because.
Thanks, Ravi.
All right. Thanks, everyone.
Quick question.
Bye.
How can I